开始。
Hi all, I'm Zoli Lu from University of Maryland, and this is our hardware demo. Our work is mainly about the propagation attacks against NTT implementations on FPGA. So number theoretic transform, which is NTT, is a spaCy subblock for lattice-based cryptography, and it is analogous to FFT on the polynomial field. And our main contribution is that the first one is we implement this very standard Koha entity on our chip whisper board, which facilitates any types of side channel analysis. So it's fully open source. You can just simply set it up in 20 minutes and do the side channel attack against NTT. It provides an end-to-end platform for side channel analysis on number theoretic transform. And the second contribution is that we are attacking the entity on the hardware implementation instead of any other simulation traces or software implementations, just like microcontrollers, which is previous researchers always do. So our work actually proves that the hardware, the NTT hardware implementation of FPGA accelerator is actually very vulnerable, which also proves that any other like fully homomorphic encryption implementation of FPGA accelerator could be also vulnerable to side channel analysis, like using our propagation attack. And the third contribution is that we are doing the attack on the whole entity process instead of one single multiplication operation, which is we are having a more practical scenario. So anyone now can simply collect one single raw trace and fit it into our belief propagation frame and review the input of the entity.
可以了，开始。
Hi, my name is Nelly. This is an implementation of NTT based on the Koha NTT, and our first step after we get the raw trace is we apply a bandpass filter on the raw trace with a center frequency of 50 megahertz, which is the center frequency of the board. And you can see here there are two stages, one stage and another stage, which correspond to the first stage of NTT and the second stage of NTT. Our second step is we apply TBLA and we find a point of interest. As you can see here, there are segments that have peaks, and these segments correspond to different operations. For example, this first peak corresponds to this first operation, and so on. After we have all the points of interest, we map them to the trace, to the filter power trace, and we downsample them and feed them into the machine learning model. Here in the machine learning model, we have 3 layers of CNN and 3 layers of LSTM, and that is a standard way of doing time series prediction. And we have downsampled our data from 1600 points to 100 points. And now, here are all the predictions coming from our machine learning model, and our next step is doing a belief propagation. And what I'm doing is a forward propagation that uses all the beliefs to calculate other nodes. And you can see here, these operations correspond to these segments in the power trace. In the Koha NTT, they do all the even numbers of operations and then do the odd operations. And now we have all the nodes calculated already. We are going to do a back propagation, and then we're going to do a forward propagation and then back propagation until it converges. Now I'm going to do a back propagation. It is the same as the front propagation, but it's doing it backwards. You can see here, it
is still doing the even number operations and then do the odd operations. You can see how the numbers change it. And now that's all of our NTT work. And this can be broken. This has shown that NTT can be broken in a single trace. And our whole process used only 1,000 traces to train and to build the template. And that's it.
That's it.